stability was a result of the permanent yield curve flattening due to the strong quantitative easing programs. Even though lower performance has been reported by Becker et al. In 2019, they are still suggesting that the yield should be viewed like Princess Cassandra of Troy, who predicted the fall of her city. Simple saying, the yield curve in their view is still informative. Looking at Grab and Tix in 2020, they validated the idea that yield curve probabilities are overestimated. Sabis and Sakhouk in 2022 said that the prediction performance is decreasing, but nevertheless, yield curve remains relevant, especially for developed countries in their view, validating the idea of Becker et al. That still the yield curve more or less could be seen like Princess Cassandra of Troy. So, simple saying, an informative indicator for recessions. SR et al. Confirms Grab-and-Tix evidence. There are noises in the information provided by the yield curves. SR et al. In fact provide a very detailed analysis of the quantitative easing program's impact on the yield curve. And the last paper, Bussier and Luisier, in 2024, shared the same logic. And having a conclusion on these evidences, for the United States and the Euro area at least, the yield curve should be adjusted for the effects of quantitative easing programs before using them for economy state prediction. In Romania, the industrial production index has shown a significant decline even starting shortly before the COVID pandemic. The Romanian economy is also showing structural changes, and the industrial production generally is seen as proxy for overall economic activity. These are the arguments, in fact, that made us believe that seeing if the classical models used for early warning is important for Romania using yield curves to see if the yield curve can tell us anything about the unfavorable situation at the industry level currently. The variable used as regressors are measures derived from the term spread. We use the level of the term spread, changes in the term spread, but we also construct a variable that indicates the number of consecutive months of negative changes in the term spread, signaling the inversion process of the yield curve. The binary dependent variable reflects whether industrial production has a positive or negative year-on-year dynamic. As a first step, the correlation between regressors at various lags and industrial output has been analyzed with the aim of using the most informative lags. Then, since all the regressors derive from term spread, the occurrence of multi-correlation must be avoided. Thus, we will analyze the correlations between variable lags to identify those robust configuration. In doing so, we aim for the highest possible prediction performance, but with minimal multicollinearity risk. The used methodology, I believe, is intuitive. Since Romania has short time series due to the late availability of the yield curve since 2007, we believe that Bayesian inference could be helpful. However, Unfortunately, we could not identify recent studies that could represent a source for relevant a priori information regarding the relationship between industrial production and yield curve. In this regard, we propose to estimate univariate logistic models with diffuse priors and then use the coefficients of the best performing estimates as informative priors into multivariate models. Thus, after setting the multivariate models with non-informative priors, we introduce informative priors from the univariate estimates for the variable that prove the best performance. The variables with lower predictive power are going to have diffuse priors in order to ensure an unbiased configuration overall. And we also take into account that linking function for the cumulative distribution functions may matter. That's why we are not using just logit models, but also probit models. The estimates are done by MCMC simulations. And speaking of priors, we are using for the logistic regressions, we are using normal distribution, and for the probit, in order to ensure consistency properties, we are also using log normal distributions. Finally, we discussed the relevance of yield curves through forecast evaluation. In this slide, we can see the variables legend. We see that we have lags for term spread, year-on-year changes, the persistence indicator stating the number of consecutive negative changes in the yield curve, but also the indicator in the exponential form. The idea is that also in the last years, for example, the United States have seen an inversion of the yield curve, but for very short periods. And in fact, those changes that didn't show anything about the economy. The economy didn't end up in a recession. And in theory, it is said that the yield curve inversion should be persistent. And that's why we believe that as we see a persistent negative change, we believe that the probability of negative industrial output change might increase even exponentially. And with this variable, we are going to check this. Now, looking at the correlation between term spread lags and binary variables, as one might expect, the more recent lags of term spread are more relevant, having a stronger correlation with the binary variable. The highest correlation is for the second lag, and the second lag is going to be the stars in terms of term spread levels in this paper, but also we are going to use the third lag, which has 0.25 correlation coefficient. Now, however, in the case of dynamics, it is observable that more distant lags present better information than closer ones. And this is favorable because the risk of multi-correlation is per se reduced. Now we see here 0.38 correlation coefficients for both 7th lag and 8th lag of term spread changes, and the highest for the 9th lag for the last lag used. Now, analyzing the relationship between the first three, the second and the third lag of the term spread with lags of changes, it is observed that the use of the second lag of the term spread is compatible with all the three selected logs of the term spread changes. But also combining the third log of the term spread with the seventh or eighth log of the dynamics could also be an option, having a very low correlation. And we can observe here the models proposed based on the correlation analysis. And we see that most of the models include the second logs, and we are checking for the exponential property of negative consecutive changes by the third variables, first with the exponential form and then with the normal indicator. Looking now at the results for univariate estimates in terms of deviance information criteria, a significantly higher performance for the logs of the term spread dynamics is seen, especially for the last log, for the ninth one. 193.8 DAC value. The level of the term spread presents, however, even less information than the indicator counting consecutive negative dynamics, looking at the DAC values. And from the univariate analysis, it appears that using the persistence indicator in exponential form does not yield a major improvement. But we are going to see what's going to happen in multivariate settings. And looking at the multivariate logistic models, we observe two distinguishing models with higher performance indicated by the DAC. The first model and the last model, the eighth one. We observe insignificant differences between those two, the first and the last logs. And that's because they are very similar. It's just the difference of one log in the term spread, but also we have seen that the correlations with the binary variable of the second and third log of the term spread are not so different, and that's why. But important to say is that exponential form of the persistent indicator brings an improvement for all the models. So using exponential form is a good idea. And we can see this if we compare, for example, model 1 with the second in terms of DAC, or the third with the fourth, and so on and so forth. Also, exploiting in the end the information from the term spread from more than one indicator seems to bring improvement over univariate estimates. Taking into account the higher performance of the first and the eighth models, these are going to be used, and we are going also to estimate them through the probit models. Which seems to give us a significant decrease in the deviance information criteria. In this case, a slight difference now is seen in terms of performance between the two models. Slightly better performance in terms of DACs for the last one. Now, as we have saw, the changes in the term spread have the lowest DAC values in univariate settings, and we are going to impose informative priors for it. Introducing a priori information from the univariate models with respect to the dynamics of the term spread, we see an improvement in terms of DAC. This confirms that Bayesian inference can help researchers and practitioners to determine future states of the economy. Prior literature evidence is not necessary. In multivariate models, informative priors can be imposed for those variables with independently high predictive ability when looking at univariate. This is our suggested approach in terms of Bayesian inference, and it seems that it provides a higher performance. Now, surely, a good question is which of the two models should be used. It turns out that using pseudo-log marginal likelihood and bias factor, we cannot find, looking at values, a clear consensus on a model. In fact, depending on the user objectives, both could be used depending on the desired horizons. Using the second log or the third log is just in fact a preference when doing the analysis. The area under the rock curve show us, however, that the last model, the eighth model, presents in any situation a better performance than the first model. Area under the rock curve shows interesting evidences. The in-sample hour rock value is about 76% for both models. If the model is estimated strictly up to 2019 pre-COVID sample, also 2019 being the point at which industrial production showed the start of declining trend, it turns out that our rock is significantly higher, about 82%. We also conducted an acid test out of sample for the period August 2023 to August 2024. And this period is short and also is very short, and also industrial production continued the started downward trend rigorously, and that's why we are calling it an acid test, a very small sample but also a very harsh time. And we expected lower our rock values, but we tried to see whether in this extreme environment our rock would stay higher than 70%, the rule of thumb. It turns out that on such a reduced interval after the COVID-19 pandemic, the performance is not so good. Our rock is under the rule of thumb value of 70%. Now, what did these results tell us? Well, they show us that the use of the yield curve still allows a moderate performance, and the yield curve should be considered. We should still use it as an early warning indicator. But the results are confirming the evidences so in literature for the euro area. Not only or for the US, not only for euro area or United States, the yield curve predictive power is decreasing. Also, it seems that most likely also for emerging economies like Romania, it is happening. Thus, the falling performance is also reflecting in emerging economies, as I said. There could even be an indirect effect of the quantitative easing programs of the major central banks. But these results definitely validate structural changes and problems. We believe that industrial production suffers from structural rather than domestic cyclical problems, and thus shows a decoupling from other cyclical components of the economy, such as retail sales, which may be nowadays more relevant for the GDP and overall economic outlook. The dependence of Romania's exports on the German economy, in particular, represents an external cyclical vulnerability. Therefore, we believe that it is important to use in the early warning models also indicators that reflect the activity of major trading partners together with the yield curve. So we are not just using yield curve for Romania, but instead we shall also use economic outlook indicator like sentiment indicators or GDP forecast for the partners, like for Romania, for the euro area, which is our main trading partner, or maybe also the foreign yield curve. For early warning of a decline in industrial production, also we observe about the yield curve a moderate performance. The probit models show better predictive ability, and Bayesian inference is helpful, especially in the context of a restricted data set. Modeling data from the yield curve seems to be a good idea. For example, we saw that an indicator stating the persistence of negative changes can in fact explain future states even better than just using the level of the term spread. Moreover, we found that as the number of consecutive months of decline increases, the probability of a negative change in industrial output increases exponentially. And here, finally, you can see the research papers that inspired us to study the subject for Romania, starting with Estrela and Harduvelis, the promoters of this subject, to the Bussier and Lussier paper, just published at the beginning of this year. Thank you very much for your attention.